In this video, let us solve more problems based on tangents to circle. And we've got a problem here which reads like this. In two concentric circles, a chord of length 24 centimeter of larger circle becomes a tangent to the smaller circle whose radius is 5 centimeters. Find the radius of the larger circle. Now, before we get into the problem, let me clear a few doubts that may have arisen already. What is a concentric circle, or what are concentric circles? Concentric circles are nothing but they are circles, many circles having the same point as the center. Now we've got two circles here, one the smaller and one more the bigger one. So both the circles share the same center O. So those are called as concentric circles, right? So those are the concentric circles. So in this question, in two concentric circles, we've got two concentric circles here. Chord of length 24 centimeters. What is a chord? Chord is nothing but a line that joins 2 points on a circumference of a circle. So this chord AB is, the length of that chord is 24 centimeters. So this is 12 centimeters and this is 12 centimeters, which makes it 24 centimeters. Now this chord of the circle, it becomes a tangent to the smaller circle. Can you see that? It meets this smaller circle at the point P. So this chord AB, which is the chord of the bigger circle, becomes a tangent to the smaller circle, just passes through this point P, and the radius of that smaller circle is 5 centimeters. So the question here is to find the radius of the larger circle. If the smaller circle is 5 centimeter radius, what is the radius of the larger circle? Well, let's see how do we go about solving this problem. Now, we've got OP perpendicular to AB. We know this from the property which says that a tangent to a circle is perpendicular to the radius of that circle through that point. So definitely this is the right angle, right? So OP is perpendicular to AB. So that is one, and then P is the midpoint of AB. It's clearly given 12 centimeters and 12 centimeters. Therefore, P is the midpoint of AB. So now, therefore, we've got AP equal to PB, which is equal to 12 centimeters. So now, in the triangle OAP, now this is a right angle triangle, right? The triangle OAP is a right angle triangle. So we've got, since the right angle is here, the hypotenuse is the side opposite to the right angle, so which is OA. So we've got the hypotenuse square, that is OA square, equal to the sum of the square of the other two sides. So OA square equals AP square plus OP square. So now what we have to find, OA is what we have to find, because OA is the radius of the bigger circle, and that is the question also. And the given data is 5 centimeters is the radius of the smaller circle and 12 centimeters is the length of AP, which is also clearly given. So we need to find OA. So OA square equals AP square. AP is 12, so 12 square plus OP square is nothing but 5 square. So we've got OA square equals 12 square is 144 plus 5 square is 25. So we have OA square equals 169. 144 plus 25 is 169. So if OA square equals 169, OA is square root of 169, which is nothing but 13 centimeters, right? So we've got another very simple problem, very fundamental problem. There's nothing much. All that you had to know was this property that a tangent to a circle is perpendicular to the radius through that point. So since we knew that it was a right angle, we just, had to identify this right angle triangle and identify that OA was the radius of the bigger circle and OP is the radius of the smaller circle. And then you knew AP is 12, and so using the Pythagoras theorem, we found out the radius of the bigger circle. This is the end of this problem. Let us quickly solve another problem, which is also not going to be tougher than this one. It's going to be easy. So we've got another question here, which reads like this. Two concentric circles are of radii 5 centimeters and 3 centimeters. Find the length of the chord of the larger circle which touches the smaller circle. Well, this is nothing but a converse type of the previous problem that we solved in the same video. So there we had a tangent which was the chord of the bigger circle, and then we had to find the radius of the bigger circle. But here we've got the radii of both the circles, and we need to find the length of the chord or the tangent. It's a chord of the larger circle but tangent of the smaller circle. So that's what we have to do. So those are two concentric circles again, so they'll have the same center. So here we've got the diagram for this. Now let O be the center of the concentric circles of radii 5 centimeters and 3 centimeters. The larger circle has got a radius of 5 centimeters and the smaller circle has got a radius of 3 centimeters. Now let AB be the chord that we're talking of, be the chord of the larger circle that touches the smaller circle. That means what? AB is nothing but the tangent of this circle, right? So in that case, we've got AP equal to PB and OP perpendicular to AB. OP is definitely perpendicular to AB because you know that property again. A tangent to a circle is perpendicular to the radius of that circle through the point. And then we've got AP equal to PB because we've got two concentric circles and then AB is nothing but a chord of the larger circle and it touches the smaller circle. So wherever it touches the smaller circle, that smaller circle, the point where it touches bisects that chord. So therefore we've got AP equals PB. Now applying Pythagoras theorem in the triangle OAP, this is not very different from the previous problem that we solved except for the fact that we need to find the length of the chord instead of the length of the tangent. So considering triangle OAP, we've got, this is the right angle, so the side opposite to right angle is the hypotenuse, so we've got OA square, that is a hypotenuse square equal to the sum of the square of the other two sides. So OA square equals AP square plus OP square. So we've got OA as 5 square and AP is what we have to find. Well, not exactly, but if you find AP, you can find AB because AB is the length of the chord. So AP square plus OP square is nothing but 3 square. So we've got AP square as 5 square minus 3 square. And you've got AP square as 25 minus 9. So therefore you've got AP square equals 16. Now if AP square equals 16, AP equals square root of 16, right? So AP will be equal to 4. So the length of AP is 4 centimeters, in which case we've got PB also as 4 centimeters. So then the length of the chord AB is going to be 4 plus 4, which is 8 centimeters. So the length of the chord of the larger circle, which touches the smaller circle, is 8 centimeters. So another very easy problem, very fundamental problem. You just have to know the property that we have applied in this problem. The property that the tangent to a circle is perpendicular to the radius of that circle through the point. So that's all. This concludes this video. I'll see you with more problems in the forthcoming videos.